Welcome back coders, this is Suraj Kelhe. In this video, I will discuss variables in Golang. Then we will discuss short declaration of variables. After that, we will look at pointers of the variables. And then we will look at the new function. At last, we will discuss the lifetime of variables. Let's start. So what are variables? In computer science, variables are abstract storage location with a symbolic name which stored a value of name or unknown type. Now let's discuss general form of variable. So here, you will need a var keyword, then its name, then the type of variable and expression. Okay, let's declare our package main in program imports a packages. Then in our function main, we will declare a local variable which will be C of type int, and we will be supplying expression equals 1. Now let's print the value. These are the two verbs, %v and %t. %v prints value of any variable as it is, and %t prints the type. Here we are using printf. Now let's run our program. So here it is displaying C of value 1 and type int. In our general form, it's not necessary that you should use this full general form. Okay, expression can be omitted or type can be omitted. Let's discuss both cases one by one. So in this first case, we are omitting the expression. We are just declaring var, name and type. Now let's print the value. Now here you can see that this string is empty. There is a variable of type string, but it is empty. So every time you define the variable in this type where you omit the expression, then value of the variable will be of type string and the value will be 0 of its type. For the string it is empty, for integer it's 0, for a boolean it's false, and for other reference types it is nil. Now let's move to our example where we omit the type itself, and at that time the type will be determined by the expression. Here we are just specifying var, name and expression. Now let's print its value as well as type. In this our third example, the value is 1 minute notes and the type is string. Okay, it is determined by the expression. If you want to initialize multiple variables of same type at once, here first you use var keyword, then put your all the variable names, and just at the end you should enter the type, and we will be printing its values and type of each of this variable, which is by default 0 and int. So if you want to initialize set of variables of multiple types, how do you do that? And at once, then at that time you use this kind of syntax. First you will use var keyword, then you will use names separated by comma and then equals, then also use the expressions separated by comma. Let's print it, and here you will see the difference. This is true and it's bool. Then 3.3, which is the expression which we allocate to this variable, and it will be determined as type float 64. Then in this third, it is of type string. Now let's import one more. Now here you can also initialize a set of variables by calling a function who has multiple return values. Here as we can see, we are opening a text file. Here we are initializing two variables, f comma error and equals the function and f dot close. Now here these two variables will be initialized. Let's look at short variable declaration. This is a short form. Here you need to specify name, then colon equals expression. You need to remember that this short declaration can only be used for local variables. Okay, so this is package main. We are importing fmt package, then we are declaring function main, and inside we are declaring the variable using this short declaration. So its type will be assigned using the expression itself. Okay, now we are going to print it. Go run. Okay, as you can see that this variable contains value 1 and it is of type int. So when to use var? Most of the time you will be using short variables. So you can use var when where the type is needed different from the value. Okay, suppose if you are assigning 100, using this short declaration you will be getting int type. But if you want a float, at that time you can use var. Here we have used var. Now again we are running. This b variable contains 100 value and it is of type float 64. In the second case, when to use var, that if the initial value is not important, or if you want to initialize the variable later in the program. Okay, now let's print the names. This is the names variable. These are its value, basically slice of string. Let's look at one more example, which is this is name and it's of type error, and see what will be its default values. Now here you can see both are nil. Now here we will defining a point struct and printing its value and its type. It's empty struct and its type is main.point. Now this one is a declaration. Okay, now how to initialize multiple values using short declaration? It's simple. Just use I, comma j or any number of variables you want to assign. Use this declaration, and after that you can use multiple values. See, the number of values or expressions on the right side should be same as the number of names on the left hand side. This should not be confused with the tuple assignment. This statement just simply swap the variables, but it is not short declaration. It is an assignment. Now initialize said by calling function with multiple return values. Just like we look at in the general form, you can also initialize using the os.open. Like using function, you can initialize the variables. Here we are just opening this file and it is returning two values. Now we are just printing the error and closing the file. One more point, that it's not necessary to declare all the variables on the left. That is, at least one new variable should be defined on the left hand side. Now check out this. Here we already defined error. Here we don't need to define error. When we specify error, this declaration will act as an assignment for this error, and this new out variable will be declared, out.close. So suppose if you use this same and on the left hand side there are no new variables. Now check out, our program will run no new variables. So what's the fix? Just use an assignment for that. See, there will be no error. Now we will discuss pointers. So what are pointers? Pointers store the address of variables. See, variables are abstract storage which store certain values. Okay, every variable has an address. That is, variables are addressable, and pointers points to variable. So let's declare a package main. We will be importing fmt package. In function main, we will be declaring a normal variable. Let's run it. Okay, this x variable has value 1 and its type int. Now we will be creating pointer to that variable. So we will be declaring pointer and we will be using ampersand operator. Okay, and this operator may only be applied to addressable values, which are variables in this case. Now p declaration ampersand of x, that is, will be of type int and it points to x. Now as you can see, this is our address. This is an hexadecimal number which is address of this variable. It is of int. Why? Because it points to variable of type int. Okay, if we want to get a value of variable using only the pointer, we can use star of p. Okay, let's save this program and run it. As you can see, the star of p value is 1 and its type is int. That is, star of p is equals x. That means that star p and x are just aliases of same variable. That means they represent same variable. Now let's update the value by pointer, that is star p equals 2, which is equivalent to x equal to 2, and we will be printing x again. Now here you can see that using star p we updated the value of x. Now let's declare pointer with its 0 value. Normally we declare variables, okay, and if we don't assign any expression, then the 0 value of that type will be assigned to that variable. Here we can also define pointers. You need to put the star preceding the type. Now we will be printing its value and its type of q. Q is of type int and it's currently stored no values. But as compared to P already has some address. Pointers are comparable. Here we are declaring a new variable of type int y, and we are comparing address of x with address of x, means both pointers, address of x with address of y and address of x with nil. Here you can get true, false, false. Okay, it's safe for function to return pointer. Now here we are declaring two new functions. One is f and one is new int. What new int does that? It creates a dummy variable and returns its address. And check out this function f. It does the same thing, just its syntax means it's much more shorter and compact. Okay, but fundamentally these two functions are same. New function is just a syntactic sugar of these two lines. Let's print the value of p. We'll be seeing the p gets updated. Okay, now p is pointing to another variable which is returned by a function. Now here you can see that each call to new int returns a different value. Now it will just return false. Okay, you can also use f function. It will do the same task as new int function. Okay, now let's pass pointer as a function argument. Suppose if you want to update any variable in the current block using the function, then what you can do that you can just pass pointers as a function argument. Here we are declaring a new function c, which is counter, and we are incrementing it. We are passing the pointers. This is increment function. This will be written int and star p plus plus and return star p. Here star p is alias of c. Aliases are basically which refer to same variables. Here means the pointers are also aliases to the same variable. Okay. Now let's look at increment ampersand of c. Here we pass the ampersand, but its side effects is that c is now 2. Inside the function, it's updating this local c. And again we use println to print c. And here c gets updated again. Now as you can see, the value of c is 3. So we have discussed pointers. Now we will look at new example of pointers, which are the flags. Flags provide functionalities that it can set a value of variable using command line. Here we are importing a flag package. Then we will be declaring flags. Flags.bool creates new variable with bool type whose name is yan. Its default value is false, and if we supply a wrong data at that time, this will be message printing. Just like that, we will be creating a string flag. Okay, this is default value and this is the message. By command line, we are updating the flags. You need flag.parse to update these default values. Using flag.args, you can get other arguments from command line which are not flags. Now we are just joining the arguments using string.join and using this separator. You are getting the value of the flag variable using star sep. And just like that, this new line, what it does that it will just omit the new line character. Now we will be building it. Go build echo flags.go. As you can see that there are two flags in our program. Hello world. Now here it will normally print the args -s. Now I will be mentioned this separator flag has value comma. The separator will become comma, and we will be using -n flag just for this. Okay. Let's look at new function. We use new function to get pointer to an unnamed variable of specific type. This is the expression of new function new, and in braces we supply type and it returns the pointer variable of that specific type. Let's look at this example. We declare package main, make imports, and then in the function main we create our new pointer, use declaration symbol, and here using new function we are supplying the type int. Now let's check out type and value of p. Now as you can see, a p contains an address of a variable which is written by new, and p is of type star int. So what value is contained in that variable? Let's look at using star p. Okay, we are printing value and type of that variable. It's 0 value and type int. Now let's update the variable star p equals 2, and let's print the updated value as well. Now as you can see, the variable gets updated. Each time address written by the new function is different. The new and ampersand are fundamentally same. Look at these two examples. Here we are defining two functions. One is f, which is returning pointer. This return pointer to an integer, and this also does the same. Now let's print the both of the values. Now as you can see, using new we get this address, and using ampersand we get this address, but both are fundamentally same. New is just a syntactic sugar. Now each call to new returns a new address. Exceptions are struct and empty array. And let's compare m and n. Here we are declaring two pointers m and n pointing to the two different variables, and we are comparing them. Now let's look at the comparison result, which is false. And exceptions are struct and int. The empty struct contains no fields, that is its size is 0. So based on the implementation, it might give the same address. And this empty array, it means that there are no elements in the array itself, and its size is also 0. At that time also it might give same address. Okay, now let's redefine new. Since new is a pre-declared function, it's not a keyword, so we can redefine new in our function. So old and new are the two integers in this delta function. Here the built-in new function is not available, and we are just returning new minus old. Let's print the result. As you can see that the value is 1. Knowing lifetime of variables can prove helpful while building high performance applications. So what is lifetime of variable? Basically, lifetime of variable is interval of time during which it exists as program execute, or in short, variable exists until it is reachable. In this example, let's first declare package main, then we will import, then we will declare a package level variable. So lifetime of package level variables are its entire execution of program. You need to only declare those variables which are necessary at the package level, because they will exist until the execution of whole program. After that, in function main, we will be declaring local variables which have dynamic lifetime. Let's discuss a for loop. This is a for loop where I iterate iterates from 0 to 3. Here I is created each time the loop begins. Inside this for loop, we are giving two statements. First, we are just printing the square of I and storing it in x variable, and then using printf, we are printing I and x. This x will be created on each iteration, and this I will be created when the loop starts. After the end of iteration, x gets recycled or reclaimed, and on the next iteration, it's again get created. Okay. After the end of the loop, I gets recycled or reclaimed. Why? Because after the end of the loop, I becomes unreachable. Now let's discuss heap versus stack allocation of variables. So variables, how we determine whether the variables are stack allocated or heap allocated. For that, let's look at two functions. First, we will be defining function f, and then we will be defining function g. In function f, here first declare variable x, then give x as 1. After that, we will be storing the address of x in our global package level variable. It means even after function finishes, variable x will exist because it is reachable using our global variable. That means the x is heap allocated because x exists even after function returns, that is x escapes from f. But in G, the case is reversed. Here y is created after the end of function, it becomes unreachable. That's why it gets recycled. That's why it will be stack allocated. Okay, now you understand how the variable can be heap and stack allocated. I hope in this video you have learned something new. To watch more such videos, subscribe to our channel 1 Minute Notes. Thank you.